I want to give you a reminder of the big picture of this unit. This is the final map, and eventually you need to understand every single piece of this map. Currently, we, we understand this part of the map. You have converted from representative particles to mole using the conversion factor 1 mole equals ARP. A meaning 6.022 times 10 to the 23rd representative particles are in a mole. It's called A because that's named after Avogadro, and it's called Avogadro's number. You also know how to convert back and forth between moles and grams. We understand that a mole of silver weighs differently than a mole of hydrogen. And in order to find the mass of a mole of a substance, you need to add the molar mass to tell you how many grams are in a mole of that substance. Sometimes this is also referred to as the gram formula mass because you use the formula of the substance to find the mass. For example, H2O, you would add the mass of 2 H's and 1 O for a total of 18.02 grams in every 1 mole. H2O, obviously, if you have a mole of it, it's going to weigh more than a mole of just hydrogen. Now we go back and forth using the conversion factor 1 mole equals the gram formula mass, and that varies for the substance. After we learn those two, you are able to do two-step problems. Starting at molecules of water, you could get to how many grams of water. For example, you would go from molecules to moles, and then moles to grams, resulting in 2 steps. After that, I added in liters. However, this only applies for a gas. There are 22.4 liters in every 1 mole of a gas. And that's true if the gas is at standard temperature and standard pressure, which I told you is a specific number. However, we're not going to learn about that number until a later chapter. So for an ideal gas at standard temperature pressure, we know every 1 mole takes up 22.4 liters of space. Then we were able to go back and forth between liters and grams in a two-step problem and vice versa. Now, my question was, what if I ask you to go from moles to liters, but it is not a gas? Well, we can do these problems if it is an aqueous solution. There's a different conversion factor for that though. And this conversion factor varies as well. It's called molarity. Molarity is designated by a capital M. If something is 3 molar, that means it has a molarity of 3. That's helpful to us because that means there will be 3 moles in every 1 liter. Molarity is a ratio. It tells us the concentration of a substance. For example, if I have a liter of acid, that doesn't help me know how many moles of acid I have, unless somebody says, oh, that acid is 6 molar. In that case, for every 1 liter I have, I will have 6 moles. Molarity is helpful because it allows us to convert back and forth between aqueous solutions and moles. So let's see the definition of molarity. If I have X molar substance, then that means there are X moles in every 1 liter. And the problem will tell you the molarity. For example, if I have 0.12 molar calcium chloride, what that means is in every 1 liter of my calcium chloride aqueous solution, I have 0.12 moles of calcium chloride. The problem will tell you that, but you're going to have to know how to interpret it. So let's try a problem. The problem is 500 milliliters of 6 molar hydrochloric acid reacts completely with an undetermined amount of sodium hydroxide. How many moles of hydrochloric acid reacted? Well, as you know, the first step is to determine what is the problem asking. Stoichiometry problems often will give you excess information. Excess just means extra. So let's find the excess information here. Well, look for the question words. Question words say how many moles of HCl. So that means we're just going to focus on the numbers for HCl. How many moles? I'm going to start off by writing the question mark. How, question mark, moles, HCl. How many moles? And then it says of HCl reacted. Well, I need to think, what is my starting number? So I look and I see two numbers in the problem. However, we're going to set it equal to the number, not the conversion factor. And we just learned the conversion factor is molarity. So I want to know how many moles of HCl are equal to the number. Equal. The number in the problem is not molarity because molarity is a conversion factor. The number in the problem is 500 milliliters. So how many moles of HCl are equal to 500 milliliters? Now I know I'm going to have to multiply by a conversion factor. However, I don't know what conversion factor to use right away, so I have to look at my map. Remember, we're starting with milliliters, and we need to get to moles. So I'm going to go back to my map. Starting with milliliters. There's no milliliters on my map. That's because it's a metric prefix. In a previous video, we talked about how sometimes you will have to start at a metric prefix, which is kind of an offshoot of the base. So I know milliliters is going to be an offshoot of one of these liters. So which liter should I use? Are we working with a gas? No, we're working with an aqueous solution. So I'm going to start right here. I'm going to imagine a milliliters box. So I'm going to first leave the milliliter and go to the liter. Then I'm going to leave the liter and go to the mole. How many paths is that? 1, 2. So this is a two-step problem. I'm going to go back to the problem now. I'm leaving the milliliter, so milliliters goes on bottom. I'm going to the mole, so moles, whoopsie, so moles would go on top, but can I go straight from the milliliter to the mole? No. I have to go from the milliliter to the liter first. That's step 1. Step 2, I can leave the liter now. And remember, whatever you're leaving, that unit goes on bottom. So I'm leaving the liter, and I'm going to the mole. So I just mapped out the problem. Left the milliliter, went to the liter. Left the liter, went to the mole. And hopefully you can see the parallels to the map. I'm leaving the milliliter, going to the liter. Leaving the liter, going to the mole. So that's how come it's a two-step problem. Now I have to figure out what my conversion factors are. How do I get from milliliter to liter? Well, I gave you a cheat sheet. Over time, you're going to have to memorize this. But in 1 milliliter, how many liters is that? Looking at your cheat sheet, you would find that's 0.001 liters. That is a conversion factor. Next, liters to moles conversion factor. How do I get from liters to moles? Not 22.4. That's what I use for a gas. This is not a gas. So I glance at my map and I notice molarity is what I need. Molarity changes and the problem will give that to us. So look up here, 6 molar. 6 molar, that means there are 6 moles for every 1 liter. So now I have set up my problem. To show you how to solve this problem, I'm going to open up my calculator. And here's what you type in. You read the problem left to right. 500 times the numbers on top, so times 0.001 times 6, and divide by the numbers on the bottom. Divide by 1, divide by 1. I have 3, so my final answer must be 3. Gotta put your label on. So 3 moles, that's still not good enough. 3 moles of what? 3 moles of HCl. Does your answer make sense? Well, we know if I have 6 molar HCl, that means there are 6 moles in 1 liter. I know 500 milliliters is half a liter, so it does make sense that I would have half of 6 as my answer. However, it's important you always show dimensional analysis. That way I can follow your thought process. Showing your work is explaining your answer. It takes a deeper level of thinking often to explain what you're thinking than it does sometimes to come up with the answer, and both are important. Explaining your thinking often takes a depth of knowledge 2 question to a depth of knowledge 3 question. And as you guys know, that can raise your grade in here to show me evidence of that deeper thought. All right, so we're going to now have all of these conversion factors at our fingertips. That's pretty intense. We're going to be able to do more complicated problems now as a result. We're going to start by trying to do a couple of those more complicated problems right now.